and welcome to this keynote speech on research information management and open science. My name is Pablo de Castro. I'm the technical secretary for the Eurocris non-profit association in the Netherlands, in Europe. And my day job is as open access advocacy librarian at the University of Strathclyde in Glasgow in the United Kingdom. Thanks very much in the first place for the invitation to speak at this fourth LIS Academy Conference. And this talk I will be delivering on research information management is a bit of follow-up on a previous talk I delivered at this international conference on changing landscape of science and technology libraries at the Indian Institute of Technology in Gandhinagar in Gurajat back in March 2019, where I also addressed this topic of research information management. The landscape has evolved quite significantly, especially in India, and we will see quite some updates on that during this talk. The index, the summary for today's talk is on the slides. We will start by seeing what RIM is, what research information management is, and what the systems that support its implementation, so-called current research information systems or CRIS systems, are. We will follow with a brief introduction to Eurocris, the association, and what it does. One of the areas that Eurocris works on is mapping the research information management landscape worldwide. So we will see a little bit how this landscape looks like at the moment. And we will finalize with a case study in open science implementation with regard to snake bites related research, which is a relevant area both for India and for tropical countries, let's put it that way. So without further ado, we start with a reference to a very recently published blog post by Aaron Tay at the Singapore Management University, where he summarized interesting reads he has come across during 2021. So this is December, late December 2021. The second of these interesting reads he highlights is related to research information management and CRIS system concepts. So I would advise you to take a look at this. It's a very short text. The URL is at the bottom of the slide, and it basically refers to a report that OCLC and Eurocris worked on that was published late in 2021 on research information management at United States institutions. So you can see the webpage where the report is available, again with the URL at the bottom of the slide. This was a summary of how research information management is being implemented in the United States, with a number of case studies for US universities looking into what workflows and what systems they're using over there. So moving on to what research information management and CRIS systems are, there is a Wikipedia page that you can see on the slide. Again, the URL is at the bottom, defining what a CRIS system is. The definition, as you can see, is a database to store, manage, and exchange contextual metadata for the research activity funded by a research funder or conducted at a research performing organization or an aggregation thereof. So basically collecting information as metadata on the wide research activity that is carried out at a given organization. CRIS systems are also known as research information management systems or RIM systems, which is usually a terminology that is mostly used in the United States, whereas in Europe, we mainly talk about CRIS systems. A key aspect of CRIS systems is the data model underpinning these platforms. This is a set of basic entities interlinked with each other, defined by the so-called serif standard or common European research information format. This is a very important data model because, as we will see in a minute, it allows the information to be exchanged across systems, meaning system interoperability. This is the serif model in a snapshot. You can see on the figure the different entities, as they're called, that make up the serif data model. The so-called core entities or main entities are shown in green on this diagram, and they comprise three core entities, three main entities, namely person, which is the researcher, organization, which is the university, the research center, faculty, department, research group, even where a given researcher works, so connected. This is normally the affiliation. And then project is the third core entity for the serif data model. This is a funded research project that is usually led or by this researcher or in which this researcher is involved, and it's also connected to the organizational unit. A project will typically have a standard metadata description as per this serif data model, including metadata elements such as start date, end date, budget, if applicable, leading institution, principal investigator, partner institutions, an abstract for the project besides its title, typically a grant number, and a funder that is actually supporting or funding the project. So each of these entities has a standard metadata set definition, and having it applied allows the information to be harmonized in a way that enables its exchange across systems and its aggregation by higher level systems such as national portals or regional portals. Around these core entities in green, you have a number of additional secondary entities within this serif model, quite a comprehensive one. Publication is probably the most important one. So publication is clearly connected to projects when applicable, connected to persons, connected to organizations. Publications are in fact part of a wider entity, which is outputs, which would include data sets or dissertations or patents. And then you have other areas such as equipment or research facilities, which are again connected to organizations, connected to researchers and publications potentially. So you have a wide range of entities that allow the whole research activity to be comprehensively described through a collection of metadata elements. So what is research information management? We will see an example here, starting with a publication. You have the journal article published in the BMJ Global Health on the screen. This was authored by a researcher at my university, Strathclyde in Glasgow. It's actually related to epidemiology in India. The URL for the article is there. It's an open access article. As you can see, this is important for open science to have access to the full text of research papers. This publication would typically be described in a repository via a number of bibliographic elements, such as the title, the abstract, the contributors, so the co-authors for the paper, their affiliations, ideally, what journal, what publisher, what issue, what pages, what DOI. That is all part of the description of the publication. Now, what research information management systems or CRIS systems allow is to complete this metadata set that describes a publication with a number of contextual metadata elements, additional metadata elements that will provide additional information that is typically not collected elsewhere, meaning not usually collected in repositories. So you have an example on the slide for the records for this publication in our quiz system at Strathclyde University, which is pure. It's just one brand of a quiz system. And at the bottom of the record, which I'm showing on the slide, you can see information on projects. This project that is shown on the slide is underpinning this publication, is referenced in the acknowledgements for the paper. You have the data set linked from the record as well, so that you can easily access the underpinning data for the paper. You can also link other aspects such as affiliations, the different affiliations for the authors. They're not shown on this screen, but because it's farther up in the record. Potentially research facilities, as I mentioned, if any institutional research facilities that are listed in an internal database for the CRIS have been used, you can link them from the record for the publication. You can link other research outputs, dissertations, patents, whatever other outputs may be connected to this paper specifically, perhaps guest talks at conferences, whatever is available in the database can be easily connected to a given publication record. So this leads to this concept of research graph, which is closely connected to research information management. You basically can see on the figure on the slide the same kind of entities interlinked with each other. So you have the researcher on top of this research graph. You have the organization there in purple color, the research data, the publications, and the grants. This is the way the research graph is currently implemented, with an important aspect being that all these entities are very frequently represented by persistent identifiers, making the information machine readable and easily linkable across entities and systems. So you know, of course, the ORCID IDs for researchers, or the ROR IDs for organizations, the DOIs for publications, and DataCite DOIs for research data. And then the grant numbers are increasingly being allocated persistent identifiers. So we would have a graph here made of persistent identifiers that are connected to each other. This research graph, or this serif data model, as I mentioned earlier, enabled the much needed system interoperability. Again, coming back to the Wikipedia page on CRIS systems, you can read there in the features section that system interoperability lies at the core of CRIS operation, both from an internal and from an external perspective. So internally, CRIS systems are collecting information on the researchers, typically coming from human resource databases, up-to-date HR databases, internal to institutions. They're collecting information on funded projects that are typically taken from platforms for project management at the institution. They're collecting information on finance, how much budget is allocated to a project, or how much of a fee is being paid to make specific papers open access. All that is kept in the finance management systems internally, again, at institutions or FMS. And then you have the external interoperability, which is even more important, whereby you can aggregate, as I mentioned, standardized information across systems and bring it together into a wide, higher level platform. And this is truly important because it allows us to collect a wider snapshot. So this is the way typically system interoperability will work when operating systems that meet the serif standard. So you have a number of institutional CRIS systems. So each of them collecting information on the research activity carried out at a university, for instance, or a research institute. And then all the aggregation, all the information, the research information is aggregated through the Serif XML metadata exchange mechanism into a national or a regional CRIS platform that allows the snapshots to be much wider, to cover a whole country or a whole region. The information exchange works both bottom up, so from institutional CRISes upwards to the national platform or the regional platform, and also top down, whereby, for instance, a national office will include all the information that can be collected at a national level, for instance, on research equipment and facilities, and bring it into the databases for the institutional CRIS systems. An example for this is the FRIS research platform, the Flanders Research Information Space. This is a regional level CRIS in Flanders, in Belgium, in Europe, with a huge number, as you can see on the slide, of entities, of information in it for researchers, nearly, over 85,000 researchers in the region, over 2,500 organizations, close to 50,000 funded projects, and close to 500,000 publications. So this comes from the aggregation of a number of universities and research centers in Flanders, in the region. You have the list on the URL at the bottom of the slide, through a carefully designed information exchange protocol that is defined jointly between the national or regional portal and the data provider organizations. Something similar to this is operating in India, and we will see it in a short while. Now, why research information is important was summarized in this contribution that we had to the CRIS 2018 conference that Eurocris organized in Sweden back in 2018. There was this submission to the conference from the so-called Peru CRIS conference, so Peru CRIS project. This is a national project in Peru, in South America, to build a national CRIS system in the country. The abstract of this submission we received from the Peru CRIS project says that in Peru, the national system of science, technology, and innovation doesn't have enough information for decision making because it doesn't have an information system to manage, namely to collect, systematize, store, and communicate the data generated during execution of each research activity carried out. This means there is no clear snapshots available at a national level on how many publications are being produced in the country, for instance, how many collaborations with industry are there, how many funded projects are there, who is funding these projects. It's a quite complex endeavor to collect all this information. You could say, okay, we can collect the publications from Scopus or from the Web of Science, and that's it. But it's not, because we're talking Peru. Peru is a Spanish-speaking country. Of course, yeah, in the hard sciences, most of the relevant publications may well be indexed in Scopus, but there's going to be a huge number of publications published in Spanish that will not make their way into the international literature databases. So there needs to be a model similar to the one I have described, whereby each institution in the country collects their information on projects, on publications, on researchers, and pushes it upwards into the national portal. And this is the project, the Peru CRIS project, that is about to, whose national portal is about to be released in the country. So coming into what Eurocris is and does, the mission for Eurocris is mainly to promote collaboration across a wide range of stakeholders within the research information community. So this is mostly universities and research centers, as I said, but also research funders, national offices for research information management in different countries, companies, vendors for CRIS systems, all sorts of academic institutions. And then the name of Eurocris suggests it's a European organization, which in a way it is. So it's based in the Netherlands, as I said, and most of its members are in Europe, where the research information landscape is most advanced at the time. But as you can see on the slide, there are plenty of members outside of Europe. And this conversation that Eurocris is fostering is actually a worldwide one, as we saw at the beginning with this report on RIM at US universities. India is incidentally on the list of members of Eurocris outside Europe. So ImpleNet in Gandhinagar is a member, an institutional member of Eurocris. So in order to foster this conversation, this global conversation, Eurocris organizes events every 6 months, has been doing it traditionally before the pandemic struck. So the last one we held as an on-site event was in Germany, in Münster, in November 2019. And in that event, we had a presentation for IRINS, the Indian Research Information Network System, by Nalan Kannan and Kimidi Siva Shankar. The slides for the presentation are available in the URL at the bottom. It was a remote presentation. It was a little bit too far to travel at the time, but you can see in the number of views, downloads, that it has been quite popular. That presentation back in November 2019. Ever since, we haven't been able to hold any more in presence, so physical events. We are hoping to be able to hold the next one in May this year in Croatia, again in Europe, in Dubrovnik, as the CRIS 2022 conference. We had to cancel the CRIS 2020 conference. We typically hold CRIS conferences every 2 years. Hopefully this one, which has a call for proposals open that you can check on this website, will run as an on-site event again, bringing together a wide range of stakeholders for catching up with what's been happening in the research information management landscape. So one key area of work for Eurocris is to map the landscape. This I'm showing on the slide is the Directory of Research Information System, or DRIS, which aims to collect records for each and every CRIS system operating out there, anywhere in the world. You can see the snapshot is strongly concentrated in Europe, but the number of CRIS systems available in India is also massive. As you can see, it's 362 CRIS systems in India, making it the top country in the classification of CRIS systems available by country, mainly due to IRINS, which has 361 implementations of these 362 CRIS systems available in India. The 362nd CRIS is a pure system, but by far the overwhelming majority of CRIS systems in India are based on this IRINS platform. The other countries on the list of largest CRIS systems by country are mostly European, so Norway, Italy, the United Kingdom, and then comes the United States. You can see IRINS as the most popular software solution, followed by Pure from Elsevier, which is the one we run at Strathclyde University, my university in Glasgow, followed by Christine, and a very large number of in-house built CRIS systems. You can explore further this map and this directory by clicking on the URL at the bottom of the slides. The slides, incidentally, will be shared after the presentation. Part of this work for mapping the landscape that Eurocris does was carried out, again, in collaboration with OCLC in the United States by running a worldwide survey, Research Information Management Survey, and a subsequent report that was published in December 2018, so a little bit over 3 years ago, with a very healthy altimetric score, as you can see. And this was the reason why I traveled to Gandhinagar to present the results of this global RIM survey. At the time, this is a slide from my presentation back in 2019. At the time, the way the RIM landscape in India was captured in this global survey was very poor. So there were only 3 responses received from India that you can see on the slide, which is a huge distance from the 362 CRIS implementations that are currently available in the country. This huge increase is a direct result of the collaboration we established back in 2019 at the conference. You have a link to the conference in Gandhinagar at the bottom of the slide. IRINS was also presented there. And as mentioned here, there was a clear opportunity for IRINS implementation, which were only starting at the time, to join the Eurocris DRIS, the Directory of Research Information Systems I just mentioned. And there will be a further iteration of this global RIM survey as soon as we kind of agree on the time schedule for this with our colleagues at OCLC. And of course, the representation from India will be much wider in this subsequent survey. The updated landscape 3 years after this earlier presentation shows, as I said, India on top of the list of countries by the number of CRIS systems, operational CRIS systems, and IRINS as a solution, again, on top of the most frequent CRIS system solutions. This is the DRIS map. So the DRIS has a geolocation feature, which allows to map the implementations, the CRIS implementation worldwide. This is a snapshot for India, and you can see that it's very widely implemented across the country. So with hubs in Bengaluru, for instance, with 50 implementations at different universities and research centers in the city or the surroundings. But then it's everywhere in the country, and it keeps growing. In fact, this is as of December 2021, so it's completely up to date. As a result of this conversation that we started with InflipNet, with the IRINS team, from a Eurocris perspective, back in 2019, there was this publication, which is currently available as a preprint in India Archive, which I authored together with Naland and Siva from the IRINS team. The title, as you can see, is The Rise of Current Research Information Systems, with an emphasis on the case of the Indian Research Information Network System, IRINS. It has seen 464 downloads. As you can see, the URL again is at the bottom of the slide. I would recommend you to take a look at this one if you can. There is a very interesting description. This is a joint work between Eurocris and the IRINS team on how the system has gradually grown, how it has been implemented, the support it has received from the Ministry of Education, how it works with the national portal called Bidwan, which is an expert finder system that we will see in a minute, in a similar way to the system interoperability model I described earlier, with the institutional CRIS implementations at the bottom, and then the information exchange with a top portal that operates at a national level. So why is a snapshot of the international research information landscape relevant? You could ask. So why is system interoperability so important? The answer is because we're often talking global research challenges. So we need to have worldwide snapshots of what the research activity looks like. This is the clearest example at the moment is climate change, of course. Climate change, as stated by this Heat and Drought Wheat Improvement Consortium, is hitting the poorest people in the world. So this organization is aiming to promote resilient agriculture in the face of climate change. It's based in Mexico, in America, but you can see that the institutions collaborating with this international, I'm going to try to move this if I'm able to. The institutions collaborating with the International Maize and Wheat Improvement Center are 444, and they are distributed across the world with big hubs in the United States, in Europe, and in Asia, in Southeast Asia. If we have a look, a bit of a deeper look into the distribution by countries of these institutions that are collaborating in this work to make resilient agriculture as part of this number 2 SDG, Sustainable Development Goal of the United Nations, India happens to be the country with the largest number of organizations collaborating with this initiative, followed by China, and then with a number of European countries well represented as well. But when you look at the research information available for these research fields, the research activity carried out in developing countries is always not so well represented in the global snapshots. So with this, we move on to this open science and research information management case study into snakebite related research, venomous snakes. This is there have been a lot of articles in newspapers about this. This is a very recent one, dated November last year, highlighting the fact that this tropical, so neglected tropical disease, as it's categorized by the World Health Organization, is particularly impacting India. This is again a sustainable development goal related research area for number 3. And it's possible to collect information on, for instance, the funded research projects. That's the largest public funder in the UK, UKRI, UK Research and Innovation, is funding in the country, usually in collaboration with other countries. You can see snakebite in South Asia, for instance, the 4th on the list, or Sub-Saharan Africa. But the lead for this project is mostly at the Liverpool School of Tropical Medicine in Britain. This is, as you can see, a SARIF compliant funder system where you can search any topic for the projects, the publication, and the people involved in this funded project in this regard. This is very rare, very rarely available outside the global north. So you have a similar portal for the European Union, the European Commission, where you can search by projects or by institutions, but it's very hard to get the information directly from a portal outside the global north. So there is a commercial software, a commercial solution called Dimensions by Digital Science that has an access for free, as you can see on the slide, and you have the URL again as well there in case you want to check it. If you access this freely available portal and search for snakebite, you can see again a wide snapshot, a worldwide snapshot of the activity, the research activity around snakebite related research, with nearly 30,000 publications, over 400 research data sets, 161 grants, nearly 4,500 patents, 38 clinical trials, and 568 policy documents. This is a much wider than just the publications. Although if you look at the publications on the left-hand side of the screen, you can see that the number is growing significantly year on year. We're near 3,200 publications in 2021, up from 2,143 in 2020. It's a massive increase. So there would seem to be an increasing interest in this topic. The WHO has expressed their intention to try to halve the number of deaths and illnesses arising from snake bites for 2030. So that is probably driving an increasing interest. Now, this is the results of the same query when filtering it for India. And you can see we had nearly 30,000 publications earlier for the global snapshot for snake bites. 12,500 of them are related to India. So it's roughly half of them are Indian. Whereas for grants, we had 161 funded projects around snake bites, and only 4 of them seem to be coming from India. I cannot click on that because it's part of the application that is not available for free. You need to have a subscription, and I don't have one. But the data there are accurate. This is the information that Dimension is collecting. Another interesting information is the most prolific researchers in these research fields. You have a list of 1, 2, 3, 11 most prolific researchers in the area of snake bites. Interestingly, the 2 first ones are based at the same institution, the University of Costa Rica in Central America. Again, a tropical country. This is a particularly interesting open science area to look into because it's a tropical disease. It's a neglected tropical disease. And although you have plenty of research activity running from the global north, from the UK, from Europe, the United States, most of the researchers on the list are based in other countries. So Costa Rica is one, but Brazil, Bolivia is one as well. Interestingly, there's no researcher based in India on the list, which is somewhat surprising and hints at the same issue I just mentioned, namely the fact that the information from developing countries is not finding its way into the global snapshots for whatever reason, typically lack of system interoperability. So we're going to look into this University of Costa Rica because they do have an institutional CRIS system. It's called SIGPRO. You have it on the slides. You have the URL as usual at the bottom, and it's only in Spanish because, again, Costa Rica, same as Peru earlier, is a Spanish-speaking country. So it's a safe guess that most of the information here is not going to be collected in an English language global platform such as Dimensions. So again, this is loosely following the SERIF data model. You can search by projects, you can search by researchers, you can search by institutional affiliations. If we search by serpientes, which is what I'm doing, snakes in Spanish, you can see 2 projects when searching by projects. One of them is running, the one in orange color. The other one is finished. Both of them are related to venomous snakes. Both of them feature the Bruno Lomonte, the researcher that was listed second on this list of most prolific researchers with 189 publications with nearly 8,000 citations for his work. If we click on his name here, which is at the core of the SERIF data model, so the fact that you can click on a researcher and collect their data as part of the data model, you can see his author record here, what academic category. He's a full professor at the Faculty of Microbiology, and there is a list of 70 research projects that he has taken part in or is taken part in. All of these 4 on the slides are running projects about scorpions, so it's not all about snake venom or snake bites, but many of them are about snakes, and they're probably connected, scorpions and snakes with regard to the microbiological analysis of venom and so on. So if you remember, we had 161 projects on the dimension snapshot, the global one. We have 70 of them for just one researcher in Costa Rica. It's, again, a safe bet that the global snapshot collected from the global north is not accurately collecting the information in developing countries. Now, I mentioned BidOne, this national portal for experts in India, the URL as usual at the bottom. You can search by snake here, or snake bite, or snake venom, and find researchers working at Indian universities who are also involved in snake bite related research. There are two of them as a result of the query on BidOne. One of them at Tezpur University in Assam, the other one at the Sri Nehru Mahavidyalaya College of Arts and Science in Tamil Nadu. Apologies for the poor pronunciation. If we click on the first one to see the record for Dr. Robin Dowley, for the researcher, you can see a lot of publications as well, conferences, projects. We can click on the projects and see who is funding them. The DBT, ICMR, DST is funding the project. All three projects on the slide are ongoing. All three are related to venomous snakes, as you can see. And you can also see the dissertations that this professor has directed or guided, 2019, 2016, 2016, again, around snakes and snake venom, all of them at Tezpur Uni. So the information is actually there, or part of it anyway. The problem is that there is no interoperability, so we're not able to expose it to international aggregations of research information, meaning that the snapshot is not capturing the open science that may be carried out in India. So here you have a number of recommendations for improving specific IDINS instances at universities or research centers in India. A number of content-related recommendations are to try and collect non-English research publications besides the English ones, to try and collect funding information. Funded projects can typically be most effectively collected at university level rather than at a country level, and then move them up to the national aggregation. There is a recommendation to connect to full text files whenever possible. This is open science. And then on the area of interoperability, a couple of recommendations for technical and social interoperability there as well. This is typically a library activity. So I haven't mentioned research libraries in my talk yet, but this is a snapshot from the RIM survey, the global RIM survey I mentioned earlier, for research information management activities, in which the library plays a significant role. And you can see a lot of activities there, mostly about metadata management, in which the library has a key role to play. So this is an important area. And this is why I mentioned Aaron Tay's blog post at the beginning. I'm not going to go much deeper into open science implementation. All of these I've talked about with regard to snake bite related research is open science. We need this science to be open, to be openly available, to be showcased. There is this paper that I would recommend you to take a look at, the role of current research information systems, or CRIS, in supporting open science implementation at the University of Strathclyde. This is a paper I wrote a couple of years ago with examples on how open access and research data management can be implemented at an institution by using a CRIS system for the purpose. And this is my talk for today. I am sorry that I cannot take questions because this is a pre-recorded talk, but you can drop me a line at my email address there if you wish to. Thank you again for the invitation, and have a nice day. Bye-bye.